All right, so for this lab, we're going to be studying projectile motion. This is a really cool video setup where we can see the video recorded from a side view, from the top, and well, I should call this the front view, and this might be a side view, looking at the girl head on as she throws the ball. So the top view can be used to measure horizontal motion, like so, and the side view can be used to study the vertical motion of the ball. So we're going to collect some data using those views. Let's scroll down and take a look at what we need to collect. We have horizontal position versus time, vertical position versus time, and vertical velocity versus time. So I've already gone ahead and set up a few of my columns, time, horizontal position, vertical position. You can see my units are seconds, meters, and meters. For time, you probably want to make sure you're using even time increments. So I'm using increments of 1/10 of a second, and that's going to be important for our calculation for vertical velocity, which you probably know because you already watched the embedded video inside of Pivot. But I just want to reiterate that point. That's going to be important for the sake of using a few points on the graph to estimate velocity. So let's go ahead and collect some horizontal position data. So I'm going to turn on this ruler, and I'm going to go back to, well, I'm at a point right now where the ball is just coming out of her hand. So I'm going to make sure my timer is at 0, and it is. And if you want, you can use this nifty tool over here to help you estimate the location of the ball. I'm going to use the front of the ball as a reference point. You could use the center, you could use the back of the ball, just be consistent, whatever you choose. Each line on this meter stick is 1/10 of a meter. So I'm going to estimate, I'm going to say it's right on the line. So I'm going to say 0.60 is the initial location horizontally of the ball. And now I'm going to fast forward to 1/10 of a second, and I'm going to move over this line until it's at the front of the ball. And I'm going to estimate, it's right on the line again, so 1.30 meters. So 1.3 for sure, and that 0 is an estimate indicating that it's exactly on the line. Now let's go up to 0.2 or 0.2 of a second. And looks like it's right on the line again. Maybe just, actually it's a little bit past 1.9. So 1.9, I'm going to say 1.93. 1.93 meters. So that would be how you collect your vertical data. Now let's collect a few vertical data points. And you would want to collect about 10 data points. I'm just showing you how to get started. So now let's go to the side view, and I'm going to put my 0 line right at the ground. Let's back up to 0 seconds, and I'm going to use the top of the ball as my reference point. And it looks like I'm at 1 point, it's just barely above 1, let's say 1.02. So it's 1.1 would be the next line, so 1.02 for my vertical height, or say vertical position above the ground. Let's go ahead up to 1/10 of a second. Just this line. I was using the top of the ball. So now I'm right on, looks like about 1.5. So since it's on the line, I'll say 1.50. Again, and moving to the top of the line, and I'm about at 1.92, let's say. Okay, and then I'll collect one more vertical data point. Let's say it's just shy of 2.2, so I'm going to say 2.19 meters. All right, now I'm going to add a column, insert column right, and call this vertical velocity. And the units are going to be meters per second. The variable will be v, or you could do v sub y. And we're going to use data points on the graph to estimate the vertical velocity. So let's go down to our graph. Let's configure our vertical axis for vertical position and our horizontal axis for time. And we have a few data points. Now, to calculate velocity, velocity is the rate of change of the position. So we need the slope that these points are making. So we want to do a linear fit. In order to get the velocity at 1/10 of a second, we would use the point before and the point after. Okay, and this is why it's important to have equal time increments. Okay, and you can see that pivot does the work for us, and we get 4.50 meters per second. Notice that I did not try to get the velocity at 0 because time equals 0 because there is no data point preceding 0. So you can't use a point before and a point after. So the first time we need to use is 1/10 of a second. So we use these 2 points and we get 4.5 meters per second. So we're going to record that 4.50 meters per second at 1/10 of a second, and then we'll turn off the first point, turn on the second, turn off the third, and turn on the fourth. And this line that's generated is the same slope as a tangent line going through t equals 0.2. And here we get a slope of 3.45 meters per second. So we can see that it's slowing down a little bit. Okay. So that's just the basics on how to get started with your data collection. Again, make sure you can collect enough data points to get a nice smooth curve, especially for vertical position. I'd recommend about 10 data points.